Have you ever wondered, how did it all begin? The universe, I mean. It's a question that has danced on the tongues of humans for millennia. And to unravel this mystery, we turn our gaze towards the realm of quantum mechanics and the Big Bang Theory. Picture, if you will, a time before time, a place before places. A singularity, an infinitely hot and dense point containing all the potential mass and energy of the universe. This little speck, smaller than the head of a pin, was the stage for the grandest of all openings, the Big Bang. In a fraction of a second, this singularity began to expand rapidly and uniformly in all directions. It was not an explosion, as the term Big Bang might suggest, but an expansion like the surface of an inflating balloon. And as it expanded, it began to cool. Fast forward a few 100,000 years, and the universe had cooled enough for subatomic particles to form and stick together. Protons, neutrons, electrons, the building blocks of matter as we know it, began to take shape. Now, if we leap forward a little further, we find these particles coming together to form the first atoms, predominantly hydrogen and helium. These atoms, drawn together by gravity, began to form clouds, and these clouds of gas collapsed under their own gravity to form the first stars. These stars, burning bright and hot, were the forges where the heavier elements were created. And these elements, when stars met their ultimate fate in spectacular supernovae, were scattered across the universe, eventually coalescing to form new stars, planets, and eventually galaxies. So from an infinitely hot and dense point, the universe expanded into the vast cosmos we see today. A cosmos filled with billions of galaxies, each home to billions of stars, and all of it from a singularity smaller than the tip of a pin. It's quite the cosmic journey, don't you think? But the story doesn't end there. The universe hides more secrets than what meets the eye. Imagine a cosmic puzzle, where the pieces we can see and touch form just a fraction of the total picture. The rest, a whopping 95%, is made up of two enigmatic entities, dark matter and dark energy. Let's start with dark matter. Despite its ominous name, it's not something out of a science fiction novel. Dark matter is simply matter that doesn't interact with light. This means we can't see it or detect it directly using our current technologies. But how do we know it exists then? Its presence is inferred through its gravitational effects on visible matter. It's like the invisible glue that holds galaxies together, preventing them from tearing apart as they spin. Now, if dark matter is the cosmic glue, dark energy is a kind of cosmic anti-gravity. It's an unknown form of energy, thought to permeate all of space, accelerating the universe's expansion. The discovery of dark energy was a real curveball for scientists. Until its discovery, they believed the universe's expansion was slowing down. But instead, it's speeding up. Despite the fact that dark matter and dark energy make up most of the universe, they remain largely a mystery. We don't know what they're made of, where they came from, or how they interact with the rest of the universe. But that's not from a lack of trying. Scientists all over the globe are conducting experiments, hoping to catch a glimpse of these elusive entities. So why does this matter? Understanding dark matter and dark energy is fundamental to understanding the universe itself. It's about piecing together the cosmic jigsaw puzzle, and every discovery brings us a step closer to seeing the complete picture. While we can't see or touch it, dark matter and dark energy make up the bulk of our universe. This is a reminder that the universe is far more complex and intriguing than we can perceive, and our quest to unravel its mysteries is far from over. Now let's shift gears and think about the most complex object in the universe, the human mind. Indeed, tucked away within our skulls is a 3-pound wonder that outshines even the most massive galaxies. This intricate marvel, the human brain, is a labyrinth of countless neurons, each with the potential to forge connections with thousands of its neighbors. Now, imagine a bustling city at night, with roads interlacing and lights flickering, a vibrant testament to ceaseless activity. That's a glimpse into our brains. Each flickering light, a neuron, and the roads, the synapses through which they communicate. These neurons communicate using both electrical and chemical signals. The electrical signals or action potentials zip along the neuron, while the chemical signals or neurotransmitters jump from one neuron to another across the synapses. This electrifying dance of signals is the foundation of everything we think, feel, and perceive. But it doesn't stop there. The brain, in its infinite complexity, takes these billions of signals and transforms them into our conscious experience. It's like a grand orchestra where each neuron is an instrumentalist playing its part in perfect harmony, creating the symphony that is our consciousness. This consciousness allows us to ponder the mysteries of the universe, to ask questions, to seek answers. It's the canvas upon which we paint our dreams and the stage where we confront our fears. It's where we experience love and sorrow, joy and despair. It's where we store our past, perceive our present, and envision our future. Yet, despite its importance, the human brain remains largely enigmatic. We are still in the early stages of understanding how this vast network of neurons gives rise to our thoughts, emotions, and consciousness. But every new discovery brings us one step closer to unraveling this cosmic conundrum. It's truly awe-inspiring to think that our brains, a product of this universe, are capable of understanding it. So as we continue to unlock the secrets of the cosmos, let's not forget the universe within us waiting to be explored. We've explored the past and the present, but what about the future of the universe? As we stand on this cosmic precipice, let's delve into the theories scientists have postulated. One possibility is the concept of heat death, a state where the universe achieves maximum entropy. In layman's terms, entropy is a measure of disorder or randomness. As the universe continues to expand, it's believed that it will eventually cool to a state of no thermodynamic free energy. This means that everything from the smallest particle to the largest galaxy will reach a state of equilibrium. There will be no stars shining, no galaxies spinning, and no life as we know it. This scenario paints a rather bleak picture, doesn't it? But hold on, it's not all doom and gloom. Another theory suggests the universe may not just expand indefinitely, but could instead go through cycles of expansion and contraction. This is known as the Big Bounce theory. The universe in this theory is like a cosmic accordion, expanding outwards, then contracting back in over and over again. Each contraction and subsequent expansion could potentially give rise to a whole new universe with its own physical laws and properties. This cyclical model of the universe introduces an intriguing notion. The universe as we know it might just be one chapter in an infinitely long cosmic story. Each cycle could bring about new galaxies, new stars, and potentially new forms of life. While these theories may sound like science fiction, they're rooted in our current understanding of physics and cosmology. They're the product of countless hours of research, observation, and mathematical calculations by some of the brightest minds in science. So what does the future hold for our universe? The truth is, we don't know for certain. But one thing is clear: the universe is a place of endless mystery and infinite possibilities. Even in its end, the universe may hold the promise of new beginnings. From the birth to the future, our journey through the universe has been nothing short of extraordinary. We've traced the origins of the cosmos back to a singularity, an infinitely hot and dense point from which everything we know sprung forth. This was the Big Bang, a cosmic explosion that set the stage for the universe as we know it. We then delved into the shadowy realm of dark matter and dark energy. These elusive entities, though invisible to our eyes, make up a staggering 95% of the universe. They are the unseen forces shaping the cosmos, with dark matter holding galaxies together and dark energy driving the universe's accelerating expansion. But the universe isn't just out there in the vast expanse of space, it's also within us, in the intricate workings of the human mind. This cosmic mystery, made up of billions of neurons, is capable of incredible feats. It is this network of neurons that gives rise to our consciousness, our emotions, and every experience we have in life. And what of the future? As we venture further into the cosmos, scientists predict a continual expansion, leading to a state known as the heat death. But even in this, there's a glimmer of hope, a possibility of cycles of expansion and contraction, of new beginnings and endless possibilities. Our understanding of the universe continues to evolve, and with it, our appreciation for this cosmic wonder. As we uncover more secrets, as we probe deeper into the mysteries of the cosmos, we realize that the universe is not just a collection of stars and galaxies. It's a story, a grand narrative of birth, evolution, and endless transformation. And we, as curious beings, are not just spectators, but active participants in this cosmic journey. So keep looking up at the stars and never stop exploring. The universe awaits with its secrets ready to be unveiled, its mysteries ready to be solved, and its story ready to be told. Our understanding of the universe continues to evolve, and with it, our appreciation for this cosmic wonder. So keep looking up at the stars and never stop exploring.